What is it?
I still don't understand transformations. Why does this have to be so hard?
We were supposed to learn that like a month ago. Here, let me explain this to you. Today we're going to be doing transformations in two different graphs, absolute value and quadratic. We're going to be doing three different transformations, translations, dilations, and reflections.
So we're going to start off with quadratics. And right now we have this quadratic and its parent function.
Now we're going to be doing vertical translations, where you move the graph up and down.
Right now we have the parent function set again. And we are going to start it off with moving it up. And this time, adding is actually going up. And so for this, we would just add 2.
The 2 represents the 2 spaces it moves up on the graph. To move it down 2, you minus 2. Now we're going to be showing you how to do translations. Translations are where you move the graph right to left and up and down. As you can see, this graph has already been translated to the right 2 spaces from the origin point. The origin point's right there. In the equation, this looks like you subtracted 2.
You always want to make sure that you do it inside the parentheses.
Now we're going to be showing you how to translate the graph to the left. As you can see, this graph has already been translated to the left 2 spaces.
So this is insanely simple. Instead of subtracting 2 like you would do if you're moving it to the right, you would just add 2.
Next, we're going to be covering reflections. Reflections are where you flip the graph over a line. We're going to be showing you how to reflect it over the x-axis and the y-axis. When you reflect it over the x-axis, it puts a negative outside of the parentheses in the equation.
Like shown.
That would look like this. When you reflect the line over the y-axis,
you would put inside the parentheses, which is why parentheses are important.
That would look like this. It's the same values for the graph because the graph is symmetrical. Next, we're going to be showing you how to do dilations. Dilations are where you stretch and compress the graph either vertically or horizontally. As you can see, this graph has already been dilated by 2 horizontally, meaning it got wider. In the equation, that looks like
this. So you're not necessarily doing anything directly to x, you're doing something to its exponent.
Now we're going to be showing you how to vertically dilate the graph. As you can see here, we have already vertically dilated it by 2. In the equation, it looks like this. Notice how we have placed a 2 outside of the parentheses. Before we just showed you how to do the transformations to a quadratic. Now we are going to be showing you how to do to an absolute value equation. Now we're going to be showing you how to do translations to an absolute value graph. We're going to be showing you how to move it to the right. To move it to the right, you minus 2 inside the absolute value signs, like shown. To move it to the left, all you have to do is add 2 inside of the absolute value signs, much like you would with a quadratic, only with parentheses. To move the graph up and down, all you have to do is add or subtract outside of the absolute value. To move it up, you add, like shown. To move it down, you minus. The 2 represents the 2 spaces we're moving away from the origin point. Now we're going to be showing you how to do reflections. First, going to be showing you how to do vertical reflections. To reflect the graph vertically, all you have to do is put the negative outside of the absolute value graph. That looks like this. To reflect the graph horizontally, you put the negative inside of the absolute value signs. That would look like this. Notice how this is the same graph. That is because it's symmetrical.
Now we're going to do dilations. And first we're going to dilate this vertically by 2. This would look like this.
On the graph, it will compress it and make content areas transformations to graphs, and this applies to algebra and geometry best. One example of our topic in a real-world context is making an equation of species population from a graph.
So the reason we choose this topic is because it's a very confusing concept to understand, and then also having to deal with the equations along with it just makes it very hard and really easy to mix up and confuse. And we wanted to figure a way where we can have it more hands-on, and because we're hands-on learners and we wanted to understand this more, and just for the fact that it's a lot easier for us personally to understand it when we actually get to manipulate the graph in real life.